are there any issues? Well, if not, then we'll go into tuples. Like, remember I said that with Python we have four advanced data types that we're going to study. That is the list, the tuples, the sets, and the dictionary. And so far we've done just the list. So today we're going to go into tuples and we'll see how far we're going to go. So today we're going to be a little bit fast since we're running out of time and there's a lot of things we have to cover. So studying list alone has given us a great advantage because when we studied strings and we came to list, we discovered that there are some methods that we used in the string class that we were able to use in the list data structure. And that's the same. The same will apply to tuples and to set. Most of the methods that we used in the list class is going to work so for the tuples. So what is a tuple? A tuple is simply a collection which is ordered on and it is unchangeable. So for instance, this is the syntax for a tuple this year, and discover that with a list we're having square brackets, but now with a tuple we're having rounded brackets. And now here the difference now between a list and a tuple, because there's sometimes I have to understand the differences between data structures so that you can know where you should use one over the other. So now you see here from the right up it says a tuple is a collection which is ordered and unchangeable. So here, for instance, when we have like this list, we have apple, banana, orange. This is the tuple that we have here. So once we have created this fruit tuple, we cannot change it. We cannot change this orange. We cannot change this banana. It is fixed like this. And it goes ahead to say the items in the tuple have a defined order, and that order cannot be changed. Items cannot be added nor removed from the tuple once it has been created. And for me, the way when I'm studying something, do I understand it? I try to visualize where I can be able to apply what I'm currently studying, and when I try to visualize that, it helps me to master that better. So now, which there are some cases that you're working with your program and you won't want to do this thing. When you're working with a program, there are some cases that you have values that you don't want to either add nor change the value. Like there are some cases that you're working with fixed values. So we discovered that if you use a list, there's some instances that maybe you might accidentally add or remove a value from that list, which is not being required. So what a tuple will do is this: a tuple will come in now to help so that the values that you have defined that tuple with cannot be changed. They are immutable. Some cases we hear tuples that are immutable means you cannot change the value once it has been created. So when creating a tuple with just one value, this is something that we have to take note of. Add a comma after the item, or else Python will not recognize it. So you're creating a tuple with just one value. Always remember to add this comma after the first item, or else Python is not going to recognize that this is a tuple. So, like I said, tuples they are similar to lists now. There are just some few things that they are going to differentiate it from a list. Like I said, a tuple is immutable or it is unchangeable once it has been created. And then now take note of this tuple constructor because it's going to be used to convert from either from a tuple to a list or from a list to a tuple. That's typecasting when we're talking about typecasting when we're still dealing with this thing with the default or the primitive data structures in Python. When we're converting from int to float, here now we're going to start dealing with tuples and lists. I'm sure we also saw today this thing, the constructor. Now, since I'm not done classes, constructors will be kind of strange. But when we get into object-oriented programming, you will understand constructor better. We understand constructors better. Sorry. So now here this tuple, this is a constructor, and this statement here is similar to this. They are the same. So this is just going to create a list, a tuple, and it's going to assign this tuple value to this fruit variable. So at the end of this implementation, this fruit variable is going to be a tuple. It's going to be of type tuple. So you have to take note of this tuple constructor. Like I said, it's going to be very, very important when we're typecasting, either converting from a list to a tuple or from a set to a tuple. So this will be really handy when we want to convert from one data structure to the other, like I've said. So now accessing values of a tuple is similar to list. Like I said, just need to pass in the index and boom, at index position one we're going to get banana. So it's the same. All the slicing methods are going to work same here for tuples. It's the same thing. Tuples is going to work for tuples as it has been working for strings and list, so it's going to work the same. So now updating values of a tuple. So this is where now we start facing some issues. Remember I started by saying that tuples are immutable or they are unchangeable. So now here when you reach a case that you want to start updating values in a tuple, now you start seeing that tuples they have a flaw, and that flaw is this: they are immutable. Once you have created them, you cannot change them. So if you really need to actually change the value of a tuple, you need to typecast it. Like I was saying, you have to take note of the this thing of the tuple constructor. So now here we have a tuple. This is a tuple. We have here apple, banana, cherry, and here now we're having now another fruit variable. So we're actually overriding this fruit variable above here. And what we're doing here is this: like I said, with tuples, they're immutable. So now if we want to actually update this list, or we want to change it, all we have to do now is this: we have to typecast this tuple. We have to convert it from a tuple to a list. Remember that with list, you can actually change the value as you want. So now here, but to actually update the values of a tuple, we need to typecast that into a list. So here we're converting, sorry, we need to have fruits here. What we need to have here was fruits. So what we're doing is this: we're actually converting this fruit into a list. And then when we're converting now into a list, what we're doing now here is this: we're actually updating banana with a new value. And after this, now we're converting back this fruit list into a tuple. So after this, we have to print now this updated fruits here. We're going to get a tuple which is updated. So now to actually update, what you need to do is this: to actually update a tuple, you need to convert it back into a list. After converting it into a list, you update the value in which you want to update. Then after doing that, you have to convert back that list into a tuple. So that's the only way that I can update tuples. So as I've been doing earlier on, we'll go through tuples, then we'll go to VS Code and we try to implement what we have understood. So now adding an item to a tuple, like I said, once the tuple is created, you cannot change it. You cannot add no remove an item from it. So from what we have seen from updating the tuple, the same will apply here. So what we need to do here is this: we need to convert that tuple into a list. After converting it into a list, we append that value. This is a list method, right? As we saw in our last class, we append that value into this fruit tuple, into this fruit list. Sorry, here we're having made a list. Then when we're done adding that value, we now typecast it back into a tuple. So that's the only way that I can add values into a tuple. And removing values is the same. So to add, remove, or update values from a tuple, you need to typecast that into a list. After typecasting that into a list, you do what you want to do, then you convert it back, or you typecast it back into a tuple. So Now, before we go to unpacking variables from a tuple, is there any issue so far? Is there any issue? Please, if there is any issue, raise your hand so that we can actually explain, so that we'll all be on a good footing before we add more knowledge to what we already have. So, like I said, like when I started learning Python, I was like, damn, what's now the need between a tuple? Why should I even study tuples over this thing? List. Seeing list will basically do. Since lists they are flexible, I just need to have a list, then I just do what I want to do with it. If I want to update, I just update easily. And if I want to delete, I just delete rather than having a tuple that has to be typecasting between one data type to another. Stuff like that. It was kind of challenging. But like I said, when you understand where you actually need to use that, then now it is very important. Then now you try to see how you can actually understand and see why that data structure was created the way it was created. So like I said, there will be some situations that you're working with fixed values, with values that you don't want that they should be changed. So when you encounter that type of situation now, then tuples are the best fit, because of some programs that you write during runtime, maybe some errors might occur, or one issue might lead to another, and that value becomes updated. And once that value is being updated, it will not yield the right result as intended. So tuples is the best fit over list when it comes to that situation. So now unpacking a tuple. So what unpacking will actually do is this. It's just going to extract the values inside this tuple and actually store them in variables. And when we settle the variables, you see you can actually create, let's say we have this variable name here, green, and we assign it a value of apple, and yellow a value of banana, and stuff like that. So now what unpacking will do is this. It's going to take these values that are stored inside this tuple and it's going to assign it to these variables. So now on this, so you have to come after executing this code, you have to print these values here. You see that the first value, apple, will be assigned to green. After that, banana will be assigned to yellow, and cherry will be assigned to red. So this is what this is going to do. So there are many ways of doing this. You can just say green is equal to fruit at index position, what index position 0. Then it's going to take that value, which is apple, or that item, which is apple, and it's going to assign it to the green variable. So this is unpacking, variable unpacking, and this will come in handy. So this is going to work to same for list. If I did not mention, so this unpacking will also work same for list. They have values that are stored in a list and you want to unpack them into variables, then you can do this. So now, so there are many ways. Like remember here, we have three variables, and these three variables, they are actually receiving these three items that are found inside this fruit tuple. So if you have just two variables here and the indexes or the items that are found inside this fruit variable, if the items that are found inside this fruit variable is more than the variables you are unpacking those values into, then an error is going to be raised. So now to capture that or to prevent that error, we make use of the asterisk. Oh, don't write that. So we'll make use of the asterisk. And what this is going to do is this. So now with this other example down here, we discover that apple is going to be assigned to the green variable, banana will be assigned to the yellow variable, and then now all the other elements or all the other items found inside this fruit variable, they are going to be assigned to red. So after executing this code, you are going to see that red is going to store, red is going to be another listen, another tuple, because red is going to store the remaining values of this tuple. So banana is going to be assigned to green, sorry, apple is going to be assigned to green, banana to yellow, and then the remaining values in this tuple is going to be assigned to red. So there'll be some cases that maybe you want to get just the first and the last value that they have found inside a tuple, or inside a list, or inside a set, or inside any data structure in Python. So this unpacking is going to be very, very handy. So let's say you wanted to get just the first and the last element stored inside this tuple. You see that now what we can do here now is this. Apple, we know that the first element is stored at index position 0, and then the last element will be stored at index position -1. That's another way that you can do that. But using unpacking, which is easier, what you need to do is this. You will just have green, which is the first variable that's going to store the first item. Then now you go ahead and you have this other variable. This, let's say red, will be in the middle now. Put red in the middle. Then now yellow will be at the end. And what this is going to do is this. It's going to take, Python is going to assign the first element inside this fruit tuple to the green variable, and then now it will assign all of these other elements into the red because of this asterisk. Then now as it's assigning, or as it has assigned all of these other elements into the red variable, the yellow variable now is going to make whole of the last element that is stored inside this fruit tuple. So that's what is going to be done. The first element will be assigned to green, the last element is going to be assigned to the yellow variable, and then now this red, the remaining elements that are found inside, that are found in the middle, are going to be assigned the red this thing variable here. And like I said above, that this red variable is going to be another tuple. So any issues? Great. So after that, we're going to see how we can loop through tuples. Maybe you just have items in your tuple and you want to print them out. So iterating over them is going to be very, very handy. So it's the same. It's the same as in this thing, as in list. That looping through, like in Python, looping through is very, through a data structure is very, very easy, no stress. So yeah, we have our tuple, this our tuple. So to loop through, what we do is same as we saw in the listing. In the loop section, we just have our for keyword for fruit in fruit. So what this does is this. So this fruit is going to make whole of the current item we're iterating over. So when we start iteration, what's going to happen is this. We start from index position 0 to index position 1, and then we stop iteration at index position 2. So during the first iteration here, when we're at index position 0, it's going to, this fruit variable is going to make whole of the item that is stored at index position 0. So that will be apple. So you have to print out this. During the first iteration, we're going to get apple. And now during the second iteration, what will happen is this. During the second iteration, we'll now go to index position 1. Remember when we're dealing with loops. It's the same what we saw on that list. It's the same here. That's the same stuff that applies. So during the second iteration, goes to index position 1, and the fruit variable is going to make whole of the banana item, and the third iteration the same applies. So for fruit in fruit is going to iterate through all the items that are stored inside this fruit tuple. So after that, there are many ways that we can go through this. We can either use for fruit, using the in keyword for fruit in fruit, or we can make use of the range function. So now with the range function, what we have to do now is this. Here we'll make use of the range function and the length. Remember that the range function now starts iterating based on a particular integer value. It starts, let's say we're iterating, it starts from a lower index right up to the value that you have passed in. So now for the range function, we'll make use of the length function. So now here, what this length function is going to return to this is the actual length of this list. So the length function is going to return 3 because the length of this is 3. The length of this fruit dictionary is this fruit tuple is 3. So this function is going to return 3 into after this code is being run, this function is going to return 3 to this range function. So now we're looking now for index in range. So now we're going to look from 0 right up to 2. Remember that with our range function, we always iterate right up to the value that we have passed, which is 3 minus 1. So 3 minus 1 will give us 2. So we're going to iterate from 0 right up to 2. And so when we're iterating the range function, what is going to be assigned now to this index now is this integer value. So during the first iteration, we're going to have 0. The second iteration will have 1, and the last iteration we're going to have 2. Then now when we have these values for 0, we'll come and pass 0 here as the index. So fruit at index position 0 is going to return apple, and then we'll print the apple out, and then fruits at index position 1 is going to return banana and cherry. So here, this is another way of doing this. So it's all left on you to choose which method you prefer, and knowing all of these other methods is very important, because there are some cases that your code looks very okay but it's not running. So when that happens, you have to start switching between implementations. So what I advise is that you should take note of the two ways of doing this, because some cases this will work, and in some cases you will require to use the range function, especially when you are working with patterns, when you want to print patterns. So that will be very, very handy. So we should take note of that. And then let me see. I'm sure that's the last thing we'll have under this here. Yeah. So we can now comfortably go to VS Code, and we see try to implement what we have seen so far with list. Like I said, list sorry, not list, tuples. I use list a lot. So now with tuples, they don't have a lot of stuff to deal with. And the best part is that since we have covered list, most of the methods or most of the stuff will also apply here with tuples. So is there any issue before we get to the implementation of tuples? Please, if there's any question, you can ask. Okay, if there is none, then so here we have a tuple. I will see my screen very well. Okay, so we have a tuple here. Fruits that stores banana, apple, and put orange. Yeah, and orange. So let's just go ahead and print this out. We have this here, and now, like I said, let's try to say what I said. Tuples, they are immutable. Let's try to update banana to, let me see, let's just call it banana 1. So banana 1, and see what Python is going to tell us. So you see that if we try to update this, we have an error. So the type error is tuple. Object does not support item assignment. This will not work. But if you discover that if this was a list, let's say I convert this into a list, and we'll have this. For instance, we will have this and we run this. We discover that this works perfectly fine. this banana has been updated to banana 1. So you will now see here that tuples are immutable. Once you have created them, you cannot actually change them. You cannot change them once you have created them. Now, like I said, for you to be able to change the tuple, what you have to do now is this. You have to convert that tuple into a list. So when you have a tuple that you need to change its value, you have to convert that tuple into a list. And to do that, remember I said you should also take note of the constructor. So for the list constructor, we just have the keyword list and your rounded brackets or your parentheses, and that's the list constructor, list constructor. Sorry. So let's try to convert this fruit tuple into a list. So let's just call it list underscore fruits, and we use the list constructor and we pass in this. I just have to add the typos. So this is what we have. And let's try to print type of. Remember when we're still dealing with the type of method that will actually return the type of the variable working with. What am I is okay type of. What's wrong with this code? So sorry, not type of type. So here, when we run that, you now see that here we have the class is a list. This is a list, but we have to run just the first fruits that we had. You see that here we're going to have a class of tuple. So now here we're actually typecast that list into a tuple. So after typecasting this, like I said, we can now actually do this thing, actually update or add values to it. Let's say we want to append what should we append to this? Let's say banana 2. No, 2. Yeah. So after doing this, if we want to print this, you see that we've actually added that banana 2 into the list. So we have to execute this. You now see we have banana 2 at the end. So after doing this, we can now typecast this list fruit into a tuple. So now to do that, let's just call this tuple underscore let's say fruit, which is equal to, now I'm making use of the tuple constructor, and then here we'll pass in the list fruit. So if we have to come and print, I'm just delete this and pass in this tuple here. We see now that our tuple has been updated. This is the updated tuple here. Let me comment this out. This is the updated tuple here. But we discovered that from the first code that we wrote and executed, when we try to update or even adding values to a list, they will say type error, tuples are immutable. So with tuples, like I said, you cannot update or change the values easily like with list. So for you to actually, or for you to be able to actually update the value of a tuple, what you need to do is this: you must convert that tuple into a list, and after converting that tuple into a list, you perform your operations, and after that, you can now then convert back that list into a tuple. So with this now, let's try to unpack what we have inside this fruit tuple. Let me just delete this and let's call this maybe fruit 1, fruit 2, then fruit 3 is equal to fruit. So we want to print now fruit 1. If you execute this, you see that fruit 1 stores banana, and let's just do fruit 2 and fruit 3. So that we see fruit 2 and fruit 3. If you execute this, you will see banana, apple, and orange. So what I've been done, like I explained in the slides, was this: banana will be stored to fruit 1. What we're doing now is unpacking. We're unpacking these values into this tuple, into these variables here. So banana is going to be stored in fruit 1, apple will be stored in fruit 2, and orange will be stored in fruit 3. I am now making use of the asterisk. So let's see what let's call this another fruit. Blah blah blah. I have time to be thinking about fruit names. So now you discover that now here we have 6 items, and we have just 3 variables that we're actually trying to unpack those 6 items to. So if you execute this, like I said, we have an error here, and now the error here is this value error: too many values to unpack, expected 3. So here what this means is this: unpacking here mean that we expect that this list should that this tuple, should have just 3 values like earlier on, but now it has 6 values. So for us to actually unpack all of these, we need to have variables that will actually contain we have to have variables that is equal to the amount of items we have inside our fruit tuple. So now when we pass in just fewer variables to unpack this, we have an error. So now, like I said, to fix that out, let's just call this fruit left fruit, or let's just say fruits left. So if we do this and we pass in that asterisk, so we discover that if we execute nowadays, we don't have an error again. And what is being done is this: let's just print out the values of the fruits left. So we have to print that out here. You see that at the end of the day, the fruits left, that is now the remaining fruits inside this tuple, is going to be converted into a list and stored inside this fruits left variable. Sorry, that when I was presenting, I said it's going to be converted into a tuple, but whereas it's going to be converted into a list. So executing that is going to unpack the first 3 items inside our fruits tuple, and we assign it to the fruits 1, fruit 2, and fruit 3 variable. And then now the remaining items inside our fruits tuple is going to convert this into a list. And when it have converted that into a list, it's going to assign that list into this fruits left variable. That's why we have this here. Is it okay? So after this, now we went ahead to talk about looping through a list. Oh, sorry, keep on saying list. Looping through a tuple. So to loop through a tuple, like we said for fruit and fruits. Now looking at just bring out what we have now in our fruit variable. So you have to execute this. You see here that first iteration we have banana, apple, orange, another fruit, and these jargons below here. So here, like I explained, during the first iteration, banana is going to be passed to this fruit variable, and when we have executed what we have inside this for block, which is just printing out the value of the fruit. Then now during the second iteration, the value of this fruit variable is going to be overwritten, and it's going to be overwritten with apple, and then we print that, and it goes on right up to the last element found inside the fruit tuple. So That's just iterating over fruit using the for loop. So now, like I said, we can also make use of the range function. And making use of a range function here now, we'll have to bring in the length of that fruit. So now let's just call this index in range of this thing will get the length of fruits. Then when we have that, we should actually print. Let's start by printing in the index first of all. So if we execute that, you see here we have 0, 1, 2, 3, and 4. These are the values that are being printed out. And you see here 1, 2, 3, 4, 5. So that's one counts from 0, meaning that we have to count right up to 5 items, and we're starting from 0, meaning that we count and end at position 4. So here, meaning that you have to print. Let's print this here so that we can actually see. Print length of fruits. So you have to print out the length of fruits here. You see we have 5, like I said. So the range function, what the range function will do is going to take this 5 and it's going to minus 1 from 8. So 1 is minus 1 from 5, we have 4. That's how it looks from 0 right up to 4. And you score that from 0 right up to 4 will give us 5. So that's what the range function is going to do. So when we're looping through this and we know that tuples are indexed, then now we can actually pass in the index that we are receiving from this range function. And when we pass in that index in the fruits tuple, we'll be able to get that element that is currently stored at that current index. So for the first iteration here, we have 0. The element stored at index position 0 is banana. And for the second iteration, we'll have 1. And apple store at index position 1. For index position 2, have orange, and so on. So that's what is going to be done. And you can also use the while loop. You can also use the while loop to do this. So for the while loop, you should make use of the listen of the range function. So for the while loop, you can make use of the range function, or you can basically get the length of the list of the tuple, then you actually do your implementations. So remember, like I said, while loops that are somehow delicate, you have to understand them very well, or else you're going to have an infinite loop. So now let's say well y index is less than the range and the length of this first, then I just print index. So now when you're coding and you're saying this, you're seeing your IDE actually flagging your variables here. The score has to hover over this. You see that index is not declared. So now here, what we're going to do is we're going to actually declare our index and we'll assign it to 0. So now you discover that you have to execute this program. You see now that we have an error. Let me see. Submitted between instances of index and range. Let me see. We have an error, type error not supported between instance and range. So here we have an error, but for us to actually look through this, what we need to do is this. We need to get an index. We need to start iteration from the current value, which is 0, and while that value, why this is less than this range. So let's remove this range function here and do this. So like I said, we have an infinite loop, and yes, so we don't even need the range function. So here we have an infinite loop. As you have seen, these zeros, they keep on printing, and this will run forever until I close this this terminal. So I must close that before that stops, like I said. So now you have to use the while loop, then always remember to actually increment, yeah, this thing to increment the variable they are actually using to actually check for this. So if we increment that and we execute this, you see now that we're actually iterating from 0 right up to 4. And now there's an issue now here. So let me just bring out this fruit and then passing that index. Let's do this out. You see here now that we have our values being printed out. But now I said there's an issue here because you want to iterate from 0 right up to maybe to the length of this fruit. We're going to have an issue because we're going to get tuple out of range. And why we're getting tuple out of range is because we're iterating from 0 and the length of this tuple is 5. When we did the check above, it gave us 5. So we're iterating right from 0 right up to 5, and you discover that we don't have any value stored at index position 5. So that's why we're having this error here, index error, tuple index out of range. So you should also take note of these small issues that might give you some small headache when you start writing maybe some small complex programs. So with this, I think we've basically gone through everything that we have studied on tuples. So is there any issue before we continue? Please, you have a question you should ask.
Hello. Uh, Hola. So, are we all following up? Seems this one is very simple. And okay, Josiane is good. Albright, are you good? Patience is good. Ojue, are you okay with it? Voila. And Janice, Janice. All right. Seems everyone is fine. Okay, there's Dia here. Dia, are you following up? Is everything okay? Uh, okay. Let me see. Dia, can you get me? Oh, okay. Somebody's having connection issues, and the slides are coming behind. Oh, sorry about that, Albright. Uh, I wish there was something I could do. Maybe you should go and stand on top of your house. Don't mind me. That was a joke. Okay. Mr. Buffon, I think you continue because everybody is almost okay. And I think even though Albright is not able to fully follow up, but she's getting some things. So yeah, after this, you share the slide, right? The section.
Yes, I will do that.
Yeah.
So after tuples, now like I said, tuples will now have a lot of methods like list. So now we have just two methods here. The count, which returns the number of times a specified value occurs in the tuple, and the index, which searches the tuple for a specified value and returns the position of where it was found. So it's the same. These other methods they apply to for list, like we saw. So it's the same stuff. So now here we'll go into Python set. So now we said a set is a collection which is unordered, unchangeable, unindexed, and do not allow duplicates. So now we said sets two are very very important, and we said they are unordered, like being unordered here. Like let me first explain ordered first of all. So we saw that list and tuples that we have just seen today, they are ordered. It means from one element to the other, they are actually distinct. So you can actually know that okay, the first element is at index position 0, and if I go at index position 0, I'm going to have, maybe if this was a tuple, you know that if you go at index position 0, you're going to have apple, and if you go at index position this thing 1, you're going to have banana. But here now with list, you don't know how the items are actually being assigned into that data structure. So you don't even, they are not indexed. So with them being under, it means they are not indexed. We don't know where an item is actually found inside that data structure. So now with sets, you see that they are also unchangeable, same as this thing, same as with tuples that we saw earlier on, that they are unchangeable and they are unindexed and they do not allow duplicates. So for tuples, we could actually have items, we could actually have duplicate items, and with list we can have duplicate items. But now here you see here that with tuples you cannot have duplicate items. Tuples will not allow duplicate items, and if there is any case that duplicate items can be stored in that tuple, what will happen is this: the last item will not be stored. The tuple will store just one item and discard the other item. So here for instance we have apple, banana, cherry, and apple. Discover that you have to print this fruit. This apple is not going to be printed out. So when we execute this program, what happens is this: we have just apple, banana, and cherry. This other apple is being discarded because this is a duplicate. And like we have said, tuples, they do not allow duplicates, and they are unchangeable, but you can actually add and remove items from the set. So now this is a difference now between now this thing, a tuple and a set. You discover that with tuples, set that are immutable. Once you have created it, you cannot delete an item or add an item or remove an item from it. But now you see that with tuples, they are unchangeable, but you can actually add and remove items from the set. So now here, for instance, we had apple, we have this set fruits, we have apple and banana. You can actually add cherry to it. This will be accepted. But discover that if we want to add apple, the apple is already stored inside this set fruit. This other apple is not going to be stored since it does not allow duplicates. So now the syntax now for a set, we're going to make use of curly brackets. I don't know how to draw this thing. Since class one I've been trying. So we use curly brackets for that. Discover that with list we made use of square brackets, and then with tuples we made use of rounded brackets or parentheses. Then now with sets we're going to be making use of what's different. We're going to be making use of this in curly brackets. So you should take note of this. So this is what we're going to be working with. So with sets are very very important. Like I said, when you know how they function and you know when you be required to use them, you will now see how valuable the data structure is, and you can actually appreciate it. So with sets, if you have any, let's say you're writing a program and you reach a stage that you don't want to have duplicates, then sets will be a better fit. Because if let's say for instance we have a list that contains maybe fruit. Let's say this was a list, and we actually typecast this list into a set. What happen is this: all the duplicates in that list, they are going to be removed. So any duplicated value inside that list is going to be removed. So that is going to be very, very important and very, very handy. So we should take note of that, of sets. So now we also have the set constructor, which will just help us to actually create a set, or is going to help us to actually typecast from one data structure to another. So to typecast from a list to a set, or from a set to a list, or from a tuple to a set, or from a set to a tuple is very, very easy. And that's one advantage that Python has a lot that I love, because with other programming languages, let's say the C family and the Java stuff, JavaScript, typecasting from one data structure to another is not that easy. But Python makes this to be very, very easy. So we just need to call the constructor and pass in the other data structure that you want to typecast, and it's going to do that for you with no stress. So remember, sets, they are unchangeable, unordered, unindexed, and do not allow duplicates. So for that, accessing items of a set, remember I said since they are unordered and they are unindexed, so you cannot use indexes or keys to actually get access to values of a set. So now here, for you to be able to access values of a set, you can basically do that by actually iterating, actually looping through those values. When you loop through the values of a set, that's when you can actually get that value, or the value that are stored inside that set. Like for a list, for instance, we just say fruits. You bring out the value that is stored at index position 0, and you're going to have apple. And for tuples, you just have to pass in the index, and you actually get that value if there's an item at that index. But now for sets, we say they are not indexed, so we cannot actually do this thing, cannot actually pass in an index. So if you pass that, that's going to fail. So for sets, we should actually get hold of the values. You have to iterate over that set. You have to look through that. So now after that, values in a set cannot be changed. Yeah, like we said. So for you to add items to a set, so you can add items to a set, although you cannot change them. So now what this statement means is this: you can actually add orange to this set, but now we cannot change. Maybe if there was a typo apple, we cannot actually update the value of this apple. No, it was a typo, you cannot actually update this. But now, like we did with this thing with tuples, if you have this and you want to actually update the value, you can easily do that by converting this into a list. After you have updated that value, then you actually convert it back into a tuple. So when you do that, that is going to work fine. So after that, let me see. So removing values from a tuple. Remember we said, sorry, not tuple, from a set. Remember we said you can actually add and you can remove values from a set, but you cannot change them. So now to remove values from a tuple, you can use the remove method, and this remove method is going to work just fine. You pass in the value. Remember, you cannot pass in an index like we did with list. Yeah, you have to pass in by the value. So when you say fruits dot remove, you pass in banana, and banana is found inside this set, is going to actually remove banana from this set. But if you pass in banana and banana is not found in this set, then an error is going to be raised. Then now they have given us two options. We have the remove and the discard. So now what the discard function will do is this: it's not going to raise any error if that item is not found. So let's say it will pass in, let's just say banana one, and banana one is not found inside this set. Then with the discard function, what will happen is this: no error is going to be raised, but with the remove function, an error is going to be raised. Remember that when an error is being raised, your program is going to stop execution. So we'll have to take note of that and see how we can try and catch those errors. As we're going to talk about error handling in later lessons. So now we can also make use of the listing of the pop function. And with the pop method, you can remove the last item in the set. But the issue here now is you won't know the exact element to be removed. Like I said, here these values will have apple, banana, cherry. They can be organized in any order. Maybe you can print this and you have this in this order and you want to print it later on. Having cherry at the first index, sorry, not index, at the first position, and apple maybe at the middle position or at the end. You will not actually know which item you're actually removing. Like for Lisa, you know that maybe I'm removing this last item and this last item can be this. With sets, you don't know where any item is being located in that set. So using the pop method will not be the best option. And then after that, we'll have the clear method that just empties the set. So we say fruits.clear is going to remove all of these items that are being stored inside this set. So there's some methods under sets that can actually do a comparison between if one set is equal to another, or if the values in the two sets are actually distinct, stuff like that. So for that, that will be an assignment that we are going to do, or you guys are going to do. I don't know if I'm going to do it. Okay, let's say that's an assignment that we are going to do. So concerning that, the other set methods, you guys are going to do that as an assignment. And let me see. The people understanding everything is so awesome. So should we actually go and bore ourselves by typing the codes on that set? Hmm? Should we do that? Push should indicate. Rose, you cannot refuse. So they send you from my back. Okay now. So since people are saying I should go and do that, that's awesome. So after doing that, it was great when I heard some people saying they had to go and research on that. They had to go and research dictionaries to come and do that tax. Then that will be fine. We'll go and take our time and code. I'm sure that we'll have an example on that set, so that after that, dictionaries to also be an assignment. Then I'll make sure to give tax on dictionaries so that we all do. That'll be awesome. So for sets, let's go again with fruits, and we have banana, apple. So let's start with this, and let's print fruits. First of all, let's print fruits. After executing that, oh god, I'm not presenting. Sorry for that. Let me present my VS Code. So what I've done is this: I've just created a fruit, a set which is a fruit. Then now we're trying to print out that after executing, we have this. I've printed all the values of of the set. Like I said, they are not indexed. So we try to index them, we're going to have an error. We have type error set object is not subscriptable. So you cannot actually index this object. So after that, we went ahead and said with this, let's talk about test about sets not being able to accept duplicates. Let's say you wanted to have an apple again here, and you discover if we execute this, you see we have just one apple, although here we have two apples here. We have two apples, but when we actually store them inside this fruit set, the last apple is not being stored. So duplicate values are not being allowed in here. sets they don't allow duplicate values. So here let's say like I said, we said you cannot actually update because now it becomes difficult now to actually know where that item is being stored. I said banana and I spelled something else. Banana. So we cannot actually change the values. Changing means we cannot actually update what we already have. But you discover that we can actually do what we can actually add orange. Let's see, let's add orange to this. And if we print this, we have orange being added. Now look at something here. Like I said, let me just delete this here. Before I even delete, look at something here. You discover that when we created this fruit set, you see that banana was the first element, apple was the second. Let's forget about this one since this one is not going to be stored. And by right, orange has to be the last element here. But if you discover after executing this program, you see apple now becomes the first element. Orange, which by right could have been the last element, now is inside the middle element. And banana now is inside the last element. So you discover that as I execute the program, the order changes. You see here, the order changes again. The first execution we had apple, orange, banana. Now we're having banana, orange, apple. Now we're having banana, apple, orange. So you see now that here, like we said, they are unordered. So here you see that this their orientation changes. Let me say orientation. Because here if this was supposed to be a list, let's say let's just say a tuple. What I've done today. If it was supposed to be a tuple, for instance. Uh yeah. Add since tuples they cannot accept duplicates or this thing, they're immutable, cannot add items to it. That's why that error. So here we have to execute this. You see that this order remains the same. Banana, apple, apple. And if I run it, no matter the amount of time I execute this order remains the same. This order won't change. And for list will be the same. But now we discover that here now with tuples, sorry, not tuples, with sets, we discover that during the first execution we have this order, and if we have to execute it again, the order changes, and if we execute again, the order changes. That's why we're saying that to actually make use of the pop function now becomes very difficult, because let's say if we say fruits that pop during each execution, we don't know which item is going to be that last item. Remember we said the pop function will always remove the item that is stored at the last index. So let's say we run that pop function and discover that now banana is instead removed. But if we're working with list, what we remove will be orange. So now we discover that with the pop function, we don't even know which element we're removing. So now it becomes difficult to actually make use of the pop function. But now we actually execute now, we discover that why they were removing that banana like that. We discover that now first execution banana was removed, second execution banana was still removed. Then now you see now that now in the third execution orange was being removed. So it's not like with list that the last item will always be removed. And that is possible with this because they are ordered, but with sets here like we have seen they are not ordered. So the best method to use is you can make use of the remove method if you are really sure that that item is actually being stored inside that set. So make use of the remove method. Banana is being removed. So irrespective of the number of time I'm going to execute this, we're not going to see banana because we actually removed it. But let's say you had a typo here and we execute this, we now see we have an key error. Banana. Banana is not found inside this banana here. The double E at the end is not found inside this fruit set. But you see that it will make use of the discard. Let's say discard, the discard function or method. You see that happened? You see that now? Okay, banana is not being found. Wait, let me just actually listen. Let's just let's just have another listen. I was executed. So people can actually see what I was explaining about. If a program crashes or if there's an error, the listen, the program is going to stop execution. So now here we're trying to remove this banana here. So if this banana is not found, our program stops execution because we have an error. Then now this statement here is not being executed. So that's what will happen. You have an error in your code and the program stops execution because of an error, then the other lines of code below they are not going to be executed. So you have to take note of that. So now here you discover that we made use of the discard function. We discovered that I was executed is being printed now out on the screen. So what the discard method is going to do is this. If this key or if this item is not found inside this set, then nothing happens. It just skips through that and no error is being raised. But with the remove method, an error is being raised if that item is not being found inside that list. I think that is all that we did for that. Yeah, that's all that we did for sets. And it's nice for running out of time. So, is there any issue? Okay, no issue as usual. As you see there. Please make sure you actually assign some pretty nice tags to rows. Say there. At least the way people understand sometimes. People make programming look so easy. So how far with the tags? Are they going smoothly or there are some issues?
My people, you people should come and talk now. Let me hear. So the task I assigned were almost straightforward. I'm sure it was good now. Nobody had difficulty. Everything was smooth, just like how this class is going smoothly. I think so. I think so, right? It was smooth. I'm sure it was. Yes, Janice. Yes, yes, they were smooth. I know. Somebody has already submitted all the three. Oh. I think I said the first person who was to submit the three task was going to get something right. But now I don't know who did it first. I will have to go and check the database and know who did it first. So who are those who completed again? I think Rose did. Dorcas, I think Dorcas did. Dorcas joined, right? I saw somebody like Dorcas joined. Where is she?
Yeah, she joined.
And left. Yeah. Okay. So I'm going to check out who submitted first, and then we'll see what to do. So you people should tell me about the task. Were they difficult? Were they approachable? Were they things that you had done? Were they out of scope? Yes, patience.
Good evening, sir.
Hello.
Okay, good evening, sir.
Yeah, good evening. Can you go ahead?
Okay, I did all of the tasks for like 1 week ago, but then I'm unable to submit. Can you just go to that submission page? It just says error. I even researched on how to do it, but it was no way.
Oh, am I the only one not hearing?
Okay, let me type.
Yeah, please try to type. I don't know. Seems you are using headset or something, earpiece or something. Uh, Rose. Seriously. So task were weapon fashioned against you. Come on. All right. What was the first one though? Oh, okay. Uh Reverser. Come on, reverser was just straightforward now. No wonder it was very easy for you. Now the other ones that were weapon fashioned against you, what were they? Word frequency analyzer or what? Somebody said temperature converter. Okay. That one was just, I think it was just if and operators. Uh, okay. We are taking note. Patience, you said you have problems submitting assignments. Can you can you explain better? Is it that you don't have access to the platform or what particularly? People are using biblical scriptures now to to describe the URL. Okay, so at the moment, yes, that was something I was supposed to do in this class. Show you people a little bit of GitHub, how to upload your code to GitHub or Google Drive. For the moment, we do not have file submission on the system. So you can only push the code to somewhere, either on Google Drive or on GitHub, and then copy the link and paste as your submission, just like you pasted the first task that was submitted. So it's the same thing. You upload your code to either GitHub or Google Drive or any other place that somebody can access, and then share the link. Also, some of you shared document links that are inaccessible. Whenever you want to share a link for Google Docs or Google Drive generally, make sure that there's a permission to view. Okay. So, patience, I don't know if that answered your question. You needed to upload a code to GitHub or Google Drive and then share the link to your Google Drive so that we can access it there. I have some interns at the office. They are working on submission modes, but I don't think it will be deployed on this current platform that you're using. But yeah, patience. Does that answer your question? Hello, patience. Okay. Was those tasks that were weapon fashioned against you like that? I hope you did not allow them to succeed. You know, you not allow them to prosper.
So they almost prospered too.
But at least they did not. No weapon fashioned
Yeah.
against you shall prosper now.
Amen.
And then when they come 1,000 to your right and 10,000 by your left, you say they shall do what? They shall not come near you. Yes, so you are supposed to kill the task. But, but it's fine. It's fine. Some tasks are meant to be like that. At least if you get to just be understanding anything, everything, then you're not learning now. Yes, no, Mr. Buffon, it's scriptures. Programmers can also say scriptures. Let me tell you that. Okay, so at least today I recorded. Let me stop my recording there.